All right, the last topic that we're going to cover in chapter 1 is about density. And you might be familiar with density. Density is the ratio of the mass of an object divided by the volume. So let's define this. So density is the ratio of the mass divided by the volume for a given sample. So for example, if you have something that's really, really dense, something like lead, it has a large amount of mass for a relatively small volume, versus something like styrofoam really doesn't have very much mass for a given set of volume. So if you think about an equivalent size piece of lead versus an equivalent size piece of styrofoam, you can tell pretty easily the lead is going to be a lot more dense. It's going to have a lot more mass for a given amount of volume. All right, so let's write this out mathematically. So if we write this out mathematically, it would just be density equals mass over volume. Another way you could write this would just be to say D equals M over V. So I'm fine with you writing it either way. But the neat thing with this is you only need 2 of the 3 variables to find the third, right? So if you have density and volume, you can find the mass. If you have mass and density, you can find the volume. If you have mass and volume, you can find the density. So there's a lot of different algebraic tricks you can use with density. So let's go ahead and do an example problem. So in this example, we've got 20 milliliters of a liquid sample, so 20.00. Let's be specific with our sig figs. Of a liquid was put into a beaker. In this beaker, we pre-measured it, and its empty mass, meaning the beaker just by itself without anything in it, was 31.447 grams. And then we weighed the liquid after we put it in the beaker. So let's write this out. So then it was weighed. The mass of the beaker with liquid was found. Let me write this out. Had a mass of 55.891 grams. What is the density of this liquid in grams per milliliter? And you may notice that densities units in chemistry is usually grams per milliliter. Sometimes if you are in a different field, you might see kilograms per liter, but essentially that's just the same. So we're just going to stick with grams per milliliter throughout most of this course. But let's just go through and do the math here. So we know that density is going to be equal to mass over volume, right? So let's first find the mass. Well, we know the mass of the full beaker was 55.891, whoops, flip those numbers, 891 grams. However, we had this empty mass up here that we need to account for, so I'm just going to subtract that out all in one equation. So 31.447 grams, and I'm going to divide that by the volume, which in this case is 20.00 milliliters. So I can go ahead and do this in my calculator, and I get a value of 1.2222, and the units in this case are just going to be grams over milliliters. It is a little bit confusing, but when you subtract 2 of the same unit, the unit just stays the same, right? So grams will be on top, milliliters will be on the bottom. All right, but we're not quite done yet. One thing you might notice is if we go back and we look at this, we had 4 sig figs, right? However, this final answer over here has more than 4 sig figs. It has 5. So we need to actually trim this down. So our final answer would be 1.222 grams per milliliter. This would be the density of the liquid that we put on the inside of the beaker. So do make sure that you don't forget about sig fig rules even when you're doing density calculations. All right, let's do another one. So let's consider this one. Let's say we have 1.00 liters of mercury. Mercury is a really cool metal. It's a liquid metal. So if you've ever seen Terminator 2, it kind of looks like that. It's this shiny liquid metal that flows around. So I have 1 liter of mercury. What is the mass? And I will give you a hint that the density is 13.6 grams per milliliter. So roughly in this question, it's saying I've got an Nalgene bottle size full of mercury, meaning 1 liter is approximately a Nalgene. What is the mass of that Nalgene bottle? So let's go ahead and plug this in. So if we go ahead and set this up, we could say, well, density equals mass over volume. But what am I trying to solve for here? Well, it says that I'm trying to solve for mass. So let's go ahead and change this up, right? So in order to solve for mass, I could just change this around and I could say density times volume is going to be equal to mass, right? Okay, so let's go ahead and do the math, but there's a few tricky things we have to watch out for. So we know immediately that the density is going to be 13.6 grams per milliliter. And in fact, I'm going to write it a little bit differently. I'm going to write it out like this. It's the same way as writing it up here. I just prefer the fraction method. So that's my density. And then I've got my volume next, right? And my volume, we know, is going to be 1.00 liters, right? But I see a problem here. You see how liters and milliliters won't cancel out here? Well, that means I need to make sure that I have the same unit set up so that both of them will cancel. So let's do a unit conversion here. And I'm going to try to keep everything in milliliters. So let's try to cancel out the liters. So I'll put that on bottom. And I want milliliters, so I'll put that on top. And if you remember your prefix values, you could say that, well, there's 1,000 milliliters in every 1 liter. So now I've got things set up. I can cancel out liters, and I've got my volume in milliliters. Once I have my volume in milliliters, this top numerator will cancel out the milliliter denominator from my density. That means that I'll be left over with grams. So let's go ahead and plug this all in. So I've got 13.6 times 1,000. If you want to do this in your calculator, you can check. But I'm getting 13600 grams. So what is that? Well, it's going to be a little bit different. You could say 13.6 kilograms. I didn't specify the unit that I wanted the mass in, but that is a lot. So one way of putting this into perspective is mercury is almost 14 times more dense than water. So if I were carrying 1 water bottle full of mercury, it'd be the equivalent of carrying 14 water bottles of water. So obviously mercury has a much, much, much higher density. Most water, instead of having a density that's this high, water at about room temperature is going to be about 1 gram per milliliter. So you can tell, yeah, it's roughly 14 times greater. All right, I hope that helps, but let me know if you have any questions.